So how do you use the definition of the derivative to find the derivative of a given function? So here we have f of x equals x squared plus 2. And they want us to find f prime of x, or the derivative of f of x. And we're going to use the definition of the derivative, which is limit as h approaches 0 of f of x plus h minus f of x over h. So to understand how to use this definition of the derivative to find the derivative of this function, we're going to have to understand how to use this function and plug it in to the definition of the derivative. And we're also going to have to understand, kind of basic, like how to solve a limit. Because once we plug it in, it's not just foiling and simplifying. You have to use some limit solving strategies in most situations when you're solving with the definition of the derivative. Okay, so in this first problem, we're asked to find the derivative of f of x, and f of x equals x squared plus 2, using the definition of the derivative, or limit as h approaches 0, of f of x plus h minus f of x over h. So the first step is taking this x squared plus 2 and plugging it into the definition of the derivative. So essentially, this is f of x, and whatever number we put here, whatever number x is equal to, we would put here, right? So if we had, let's say, f of 4, where would we put that 4? We would put the 4 in place of the x, so we'd have 4 squared plus 2, right? So now in this situation, what we're being asked to do when we're plugging it in, we have f of x plus h. So where would this x plus h go? It would go in place of the x, right? So we would have x plus h squared, and then plus 2. And then f of x is equal to x squared plus 2. So for f of x, we just plug in x squared plus 2. So it's minus x squared plus 2. And then that's all over h. So the first thing we're going to want to do is FOIL x of x plus h squared. So x plus h squared is equal to x squared plus h squared, right? X squared plus h squared plus 2hx, because we have hx and then hx, so plus 2hx. So now let's rewrite it. And make sure always when you're showing your work, like if this was a free response question, you'd want to always, each step you want to write limit as h approaches 0. You don't want to forget about writing this, because sometimes you'll get points taken away on a free response question if you're not including this on every step. So limit as h approaches 0. Now we're going to rewrite it. We have x squared plus h squared plus 2hx plus 2. And then we're going to distribute this minus, so minus x squared minus 2, right, because we're distributing the minus. And then that's all over h. So let's find what we can cancel on the top. So we have positive 2 and negative 2, so that can cancel and that can cancel. And then we have positive x squared and negative x squared, so that can cancel and that can cancel. And now what we're left with is limit as h approaches 0 of h squared plus 2hx over h. So now, if we plug in, let's say we plug in 0 at this step right here, we're going to have 0 squared plus 2 times 0 times x, which is 0, so 0 plus 0 over 0. So we're still going to get 0 over 0. So another thing we can do to simplify this even further is factor out an h from the top and then try to cancel it with this h on the bottom. So if we do that, we're going to have limit as h approaches 0 of h times h plus 2x, right? Because if we were to distribute this h, we would have h squared plus 2hx. And that's over h. So this h can cancel with this h. And now we're left with limit as h approaches 0 of h plus 2x over 1. And now we're at the step where we can plug in the 0. So we plug in the 0 for h, and we get 0 plus 2x over 1, or 0 plus 2x over 1, or just 2x over 1, which is equal to 2x. So the derivative of x squared plus 2, or f prime of f of x, is equal to 2x. And that would be your final answer. Okay, so here's a practice problem. You can go ahead and pause the video and try it if you want. So the first thing we're going to want to do is it's the same process as last time. So this is f of x, so whatever's here in place of x, we put in place of x in the equation. So if we have f of x plus h, we're going to put x plus h in place of the x's in the equation. So we have 3 times x plus h squared plus 2 times x plus h plus 2, and then minus f of x. So f of x is equal to 3x squared plus 2x plus 2. So when it says minus f of x, we just do minus f of x, right? So minus 3x squared plus 2x plus 2. And this is all over h, and we have limit as h approaches 0. So the first step is simplifying, or expanding rather, the top. So let's start with 3 times x plus h squared. So we know from last time x plus h squared is equal to x squared plus h squared plus 2hx. So we have 3 times x squared plus h squared plus 2hx. And then we have that plus, distribute this 2, plus 2x plus 2h, and then plus 2. And then let's distribute this negative. So we have negative, or minus 3x squared minus 2x minus 2. So now let's rewrite that down here. So we're making sure we show all of our steps. It's all going to be over h. And let's also expand, or let's distribute this 3 while we're at it. So we're going to have 3x squared plus 3h squared plus 6hx, because we had 2hx, so 3 times 2, 6hx, plus 2x plus 2h plus 2 minus 3x squared minus 2x minus 2. And now let's look for what we can cancel. So I see we have a positive 3x squared and a negative 3x squared, so those two cancel out, those become 0. And I also see that we have a positive 2 and a negative 2, so we can cancel those. And then we have a positive 2x and a negative 2x, so we can cancel those. And then nothing else on the top can be canceled. So we're going to rewrite it now that we've canceled out some of the variables. And we're going to have 3h squared plus 6hx plus 2h all over h. And now we're going to do exactly what we did last time. We're going to have limit as h approaches 0, and we're going to factor out an h from the top. So we're going to have h times 3h plus 6x plus 2. And then we're going to cancel these h's, so it's going to be 1 over 1. So we're going to have limit as h approaches 0 of 3h plus 6x plus 2 over 1. That's not right. Yes, it is right. And then we're going to plug in, now we're going to plug in 0 for h. So we're going to have 3 times 0 is 0, plus 6x plus 2 over 1, right? So that's equal to 6x plus 2. So that's our final answer. F prime of x is equal to 6x plus 2.